Recently, there was a mysterious, uninvited guest hiding behind the sun. He was the internet celebrity, Sanai Atlas. Now Atlas is at perihelion closest to the sun, and his closest moment to the sun will appear on October 29th. At that time, his distance from the sun will be about 210 million kilometers. It's not particularly close to the inside of Mars' orbit, but this will be his most active moment. But unfortunately, we can't see this ballet, because the Earth's observation angle is too poor. The bright light of the sun completely blocked the perihelion of Atlas. We can only wait for him to come out from the other side of the sun. Astronomers have found that there are three obvious anomalies in Atlas. The first is that the size difference is too great. The maximum diameter of the OMA is only 400 meters. The Borisov is about 1 kilometer, and the Atlas can reach 5 to 6 kilometers, which is several times that of the first two. The second point is that the speed is too fast. OMA and Borisov are already considered fast, but Atlas is twice as fast as them. It is considered the best in the history of solar system observation, and this third point is also the most abnormal. OMA came from the north side of space, and that direction was the same as the direction of movement of the solar system in the Milky Way, so it was a chance encounter. Although Borisov came diagonally, he did not deviate too much, but Atlas crashed in sideways. Planets in the solar system, asteroids basically revolve on a flat disk. The orbit of Atlas is only 3 degrees off this disk. In three-dimensional space, it can come exactly along this plane. It is simply a coincidence with a very small probability. We know that Atlas is from the center of the galaxy, but to find his hometown, we have to look at the galaxy from a different angle. The Milky Way, like the solar system, has most of its matter in a thin disk, but above the thin disk, there is a sparse back disk of matter. There are not so many celestial collisions in the back disk, superplanets explode, and the celestial bodies can stay safe for a long time. Astronomers speculate that Atlas came from here. How old is this hometown? It may be 7.6 billion years old, almost 1.6 times the age of Earth, and older than the solar system. Although it's impossible to trace its complete journey from birth to the present, astronomers have calculated its trajectory over the past 10 million years. During those 10 million years, it came as close as 0.3 light years to other stars at one point, essentially traveling alone. In fact, as early as May 7, 2025, the TESS Exoplanet Survey satellite photographed Atlas when TESS happened to be observing exoplanets in its direction and inadvertently recorded it for a month. This data proved invaluable. Astronomers found that Atlas's brightness actually increased 5-fold between May and June, far exceeding the expected 1.5 times. The surge in brightness indicates it's reflecting light, not emitting its own, forming a coma on its surface. However, this led to new anomalies. The coma appeared too early. Ordinary comets don't develop comas until 3 to 4 AU from the sun because they're mainly water ice and need enough sunlight exposure to sublimate. But Atlas had a coma 740 million kilometers out because its coma is full of carbon dioxide with an 8:1 ratio to water, the exact opposite of ordinary comets. Carbon dioxide, or dry ice, can sublimate directly at low temperatures, hence the early outgassing at aphelion. The second anomaly is reversed light polarization. Sunlight scatters off celestial bodies. Most, including Borisov, scatter light vertically to the sides. But Atlas has negative polarization, the most extreme of any celestial body discovered. This shows its surface composition is completely unlike solar system bodies, proving it's normal matter from another star system, an outlier in our terms. The third anomaly is the separation of nickel and iron. In the universe, they're basically inseparable, both ejected when stars die and absorbed together by celestial bodies. But summer observations of Atlas showed only nickel, no iron, which didn't suddenly appear until late September when the nickel-iron ratio returned to normal. Astronomers speculate that during the early carbon dioxide sublimation, only water was brought out, but where the iron went is still not fully understood. There was also a small anomaly at the end of Atlas's tail. When I first saw its tail in the summer, it was actually facing the sun, but a normal tail should be facing away from the sun, because the solar wind pushes matter in the coma in the opposite direction. I only figured this out later. At that time, it was still far from the sun, and the solar wind was not strong enough. The dust from the carbon dioxide sublimation was not blown away, but instead piled up on the sunward side, making it look like a reverse tail. In September, when it got closer to the sun, the solar wind became stronger, forming a normal short fan-shaped tail. Not all comets have long tails. Tail length is related to the comet's distance from the sun. For example, Comet Hale-Bopp in 1997, 130 million kilometers from the sun, had an ultra-long tail, while Atlas recently was only 200 million kilometers away, so its short tail is normal. October 3rd is a good opportunity for observation. That day, Atlas will be only 28.42 million kilometers from Mars, the closest it will be to any planet in the solar system. The Opportunity rover on Mars's surface and the ExoMars orbiter around Mars both took pictures, but the results were not great. Opportunity's camera is not meant for this. It needs a 30-second long exposure and image stacking, but in the end, it only captured a streak of light. ExoMars images are a bit clearer, but the coma and nucleus still can't be distinguished. For clearer observations, we'll have to wait until early December. At that time, the sun won't be in the way, and we can see its effect on the comet. However, there is one small regret. NASA's Mars Reconnaissance Orbiter has the most powerful telescope and should have taken more detailed images, but due to the US government shutdown, staff couldn't go to work. So either no images were taken, or they weren't released. Before it leaves the solar system, there's one last observation chance. On March 16, 2026, it will be 53.85 million kilometers from Jupiter. The Juno orbiter around Jupiter may take a final photo.